Hey there. If you're having questions on 86, I'm just going to go over kind of these problems, and they're asking you to combine like terms or use the distributive property. And the harder part is probably the distributive property, not the combining like terms. So when we look at A, what I have is I don't have necessarily a distributive property. What I have then is just combining like terms. So what I have for this is putting these x terms together and then also putting together the number terms together, right? So when I put together the x terms, right, if we think about these as algebra tiles, I have 10x algebra tiles, 10 x tiles, and then I have 8 x tiles. How many do I have total? I have 18 x tiles, right? And then what I do after that is I'm looking at all these numbers. I have all of those single tiles, right? I have 4 of those. I take away 3 of them, and then I add an additional 2, right? So when I do that, I'm going to end up with a what? Plus 3. Right, so that's it. Now, if you were to do this with distributive property, the distributive property is if you could put them in groups, right? If I had 18 x tiles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. But then I also have 3 1 tiles. Maybe I should put those in a different color. 1, 2, 3. If you notice, I kind of put them together specifically in a group. What was that group? The group, I have 3 groups, right? You can see that I probably should have put them more horizontal than vertical. But if you see, I've got one group, right, here that has 1, 2, 3, 4, 5, 6 x tiles. Those I did in black with one tile, 1 unit tile. And then I have another group here and then another group there. So I have 3 of those. So if we take a look at it, we have 3 groups of what? 3 groups of how many x tiles? We have 3 groups of 6 x tiles plus a 1 tile for each group. Okay. Now notice I still have the same amount, whether you look at it as 3 groups of 6 tiles, x tiles plus 1 tile. I have a total of 18 plus 3, and so these two are what we call equivalent. They're the same thing. Okay. All right, let's look at B. B, I'm going to group things very similarly again, and what I'll do is notice in here I do have one group of the x squared tiles, and then I have a group of x tiles, which I'm going to have to kind of put some focus here. We'll talk about that. Whoops. We'll talk about that, but I'll kind of I'll talk about, well, we know, I guess, I don't need to, I guess, just pause in this. We know that we have 2 groups of an x tile and 2 subtract 1 unit tiles, and we didn't talk much about the subtract 1 or the minus 1 unit tiles, right? But we have 2 groups. So what this whole thing becomes right here is 2x tiles minus 2 1 unit tiles. Okay, so that's what that equates to. So now when I go to grouping stuff, I have here all my x tiles, and then when I go to my 1 tiles, I have 1. Now I'm going to ignore everything in that black circle. Here's my minus 2, and there's a plus 3, right? I don't need this anymore. Why? I have it all written up right there, okay? So now just group those tiles together, and I have an x squared tile, one of them. Then I have how many of the x tiles? I have 2x and another 2x, so that's plus 4x. And then what do I have at the very end? I have a 4, a 3, and a minus 2, so that's going to be a plus 5. Okay? All right. Whoops. Now, two more examples here. Let's look at this one. C, I can't group any of these together because I already have 3x squared tiles with a minus 48x tiles. So in this case, all we're going to do is we are going to look at this as a distributive property type problem, okay? So if you could think about it like this, I have 3x squared tiles, 1, 2, 3. You know what? I'm going to group those here. There's my 3. Then let's just think about, don't worry about that minus sign for now, just worry about the 48x side, and let's put our focus towards that. Well, could I group those 48 up? Yes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm not going to draw all those out because that would take a long time to do that, but we can divide that 48 into 3 groups. And how many will be in each group, right? 16, right? There'll be 16 in this group, 16 in this group, and 16 in this group, okay? So what I can do is I can rewrite this as what? 3 groups, 1 group, 2 groups, 3 groups, 3 groups of what? Of x squared. Then we have a minus, right? What? 16x for that. Now, if you look at the answer, there is one other thing that they ask you to do. If you had this, I'd be okay with that, right? I'd be all right. But if you start to pick up on a pattern, what you're doing is you're looking for, if we look up at A for just a second, right? Let me choose yellow, the color we haven't used yet. If you take a look up here, how are these all connected, right? I noticed that 18 and 3, the greatest common factor of 18 and 3 is 3, right? And then 3 times 6 is 18, and then 3 times 1 is 3, right? So when I'm looking at this problem, what's the greatest factor, greatest common factor of 3 and 48? Well, it's 3. Now, put your attention towards the variables. What's the greatest common factor of x times x? Because that's what x squared is, x times x and x. And what's the greatest one for that? The greatest one for that is also x. Right? Because this is x times x, and that is also an x. And just like I had a 3 here and a 3 times 16 here, I also have these x's that I can put out front. So I have a 3x, because there's an x in each term. What remains? An x from the first term minus, when I took the 16 out, I'm sorry, when I took the x out of the 16x, what was I left with? What is going on? It's going crazy. Okay. There we go. It's minus 16, right? I know why. There's a little rectangle underneath and I must be bumping it and highlighting it. Okay. There's minus 16 there, right? A little confusing. If you had the top one, I'm happy. If you have the bottom one, even more happy. Let's do this one. Let's now use our brains and say, okay, what's the greatest common factor of 75 and 15? And the greatest common factor is 15. What remains, right? What remains? How many 15s go into 75? 5 of them. Minus, how many 15s go into 15? 1, with an x remaining. So that's a good answer. You don't have to have that one, so you could write 15, 5 minus x. That's great too. Either one. Okay? Let me know if you have any other questions. Have a great day.